Hi guys, coming at you with a video about solving right triangles. We are talking about trigonometry involving equilateral triangles and squares. In this video we get to see, partially, how trigonometry can actually be used. Alright, let's get started. We have 3 examples. Here are some formulas that we need to know in order to be able to solve the problems that are going to be in this presentation. The difficulty here is that unlike the previous video where we go through a set of steps once we recognize what we need to find, here you have to apply some knowledge regarding squares and equilateral triangles. On top of that, you really have to think through what you're looking for. So in the previous video, the triangles are marked off for us. Here, we have to figure out what we want. That's an application of knowledge problem, which makes things kind of tricky. So let's take a look at the first example. In this problem, we need to find the area of this square. We need to know a couple of rules about squares. If you're familiar with proofs, geometric proofs, you actually might have proven some of these theorems. So the first thing we need to realize is that this diagonal here bisects this right angle, creating a 45-degree angle here. I also have a 45-degree angle here. But for this example, I'm just going to keep the 45-degree angle at the bottom. Since this is a square, all sides are congruent. So it does not matter which side I find. I am going to use this side. And the only reason why I'm going to use that side is to create a contrast from this example to the next example. But I definitely could have picked this side because this triangle that was created by this diagonal is isosceles. So now I'm going to go through the process of finding that side using trigonometry. I'm going to label the sides of my triangle. So this is O, or opposite. This is adjacent. And this is hypotenuse. As I mentioned before when we were talking about the equations, if you need a refresher or to understand these steps, you can check out the trigonometry video that I posted. Now, adjacent and a hypotenuse is going to use cosine. So just a quick review, we have sine of theta, which is O over H, cosine of theta, which is A over H, then tangent of theta, which is O over A. That H looks like an A. There we go. I am using this ratio here because this is what I have. So I'm going to plug in my information and cross multiply and solve. If you're getting more familiar with trigonometry, I still stand by the idea that I would not skip the cross multiplication. If you go an extended period of time without using trigonometry, you're not going to remember, or you may not remember, I should say, when you multiply or divide these functions. So when I plug this into the calculator, I get 7 square root 2 over 2. In almost all of my videos involving plugging into the calculator, I make a big deal about having a good one handy. My calculator uses Math Print, I think, which is what TI calls it. I believe Casio now calls it textbook print. So it is a massively helpful technology and not expensive. Now, I need to find the area. The area of a square is right here, is A equals side squared. A equals 7 square root 2 over 2 squared. One of the arguments I keep making is that this is easier. It is easier than using a decimal. I do not need a calculator at this point. So let's just take a look at some of these rules. They are worth knowing as you go into different algebra classes and you go into more advanced math anyway. The way this works, so the arithmetic rules are that square will distribute to every digit in this fraction. 7 squared is 49. The square root of 2 squared is 2 over 4. There's a couple of shortcuts here I can take at this point that I am not going to. I want you guys to see how this works out step by step, and then you can start finding shortcuts from there. 49 times 2 is 98, and now this reduces by 2. I had to double check it with my calculator, but 49 over 2. And you can keep the area like that. Alright, a couple of things I want to bring up here. So, if I were to punch square root of 2, 7 square root of 2 over 2 into the calculator, that would be 4.9497. Squaring this in the calculator is the only way I can manage it. When I get these answers, I don't need a calculator anymore. Alright, I want to look at one more way to solve this problem. Then we're going to move on to the next example. Because this problem is a square, I can use Pythagorean theorem. And the reason why I could use Pythagorean theorem is because both of these sides are the same. So I'm going to apply the same letter to both sides. If you need a review on how to apply a Pythagorean theorem, you can check out the video I posted, or there's a million videos out there, I'm sure. I always start by labeling C, which is the hypotenuse, then A and B here. So now I'm going to plug in to the theorem, and I'm going to solve. So 7 squared is 49, x squared plus 2, x squared plus x squared is 2x squared. I'm going to divide by 2, and now I'm going to get x squared equals 49 over 2. If you notice, the area has already made its appearance. But, because we're just looking for the side, I just want to finish it. But if you choose to stop there, you can. So now I have 7 square root 2. You cannot have a square root of 2 in the denominator. So there's a bit of a process to solve this. And I am sharing all of these little rules with you in hopes that they will just look familiar later when you take other math courses. So what I need to do here is I need to rationalize this fraction so the square root is no longer on the bottom. 7 times the square root of 2 is 7 square root of 2. Then the square root of 2 over this time, the square root of 2 times the square root of 2 is 2. So you can see we got the same answer twice. To be fair, if I chose to, I could have just punched the 7 square root of 2 into my calculator and it would have rationalized it for me. If I would have just typed into the calculator square root of 49 over 2, it would have rationalized it for me. So it is about the same amount of steps. It's entirely up to you which way you want to approach this problem. Alright, let's take a look at the next example. This example covers all of our bases for an equilateral triangle. It also addresses one of the concerns in the beginning of this video, which is to know what you are looking for. In this specific example, the altitude is provided. That's called an altitude, often referred to as the height of the triangle. Now we have to find a width, a perimeter, and an area. So let's get started. In an equilateral triangle, this angle is 60 degrees. It is so because all three angles in this triangle are congruent, and they need to add to be a total of 180 degrees, or half a circle, or half a square or a rectangle. So this is all related. Now what I'm going to do is I have to choose which side I want to find. The altitude cuts the base in half, but I can find this side here, and that will give me all three sides of the triangle. I can find this side if I want to, but then I would have to multiply the answer by 2. There is nothing wrong with that. Now what I'm going to do is I'm going to use trigonometry to solve this problem. In this case, because I don't know what this bottom part are, I only have one side of the triangle, so I cannot use Pythagorean theorem. This problem will use sine, because sine of theta is equal to O over H. I am now going to plug into that ratio and create a proportion, just like I did the last time. And I'm going to cross multiply and solve. So that's 8 equals, let's see if I can write it 8 like a normal person. There we go. Sine 60 times x. And now I'm going to divide sine 60 because x is not by itself. Then I have this, which when I plug into the calculator, I get 16 square root 3 over 3, which is an ugly looking number, but I promise you it's going to be easier this way. So now I have my width, because all of my sides here are the same length, is 16 square root 3 over 3. To find a perimeter, all I need to do is multiply this number by 3 because there are 3 sides, or add the 3 sides together. So I could have done 16 square root 3 over 3 plus 16 square root 3 over 3 plus 16 square root 3 over 3, which is the same as multiplying by 3. Well, again, for those of you guys who are not familiar with your arithmetic, which is okay, I'm going to multiply across and do this the long way. So 3 times 16 is 48 square root 3 over 3. 48 is divisible by 3, as we know, which brings me back to square root 3 over 3. Quick side note, which I will show you, is sometimes you will see math people just kind of randomly cross these out, making it look like they're all making up the rules. This is the reason why here. Alright, let's find the area. I am once again going to insist on keeping my answer this way because it will be quicker. So from here, what I can do is I can multiply 8 by 1/2 and get 4. there's a couple of ways I can handle this. Then 16 times 4 will be 64. And 64 is not divisible by 3, so I am done. There's a couple of combinations I could have done there to solve that problem. I could have turned it into 16 square root 3 over 6. I'm pretty sure, and gotten the same answer. I just went with the even number and divided it by 2 and then solved the problem. That's it. Alright, let's take a look at the next example. This is a commonly asked question and it requires a lot of application. So let's get started. The perimeter of this square is 64. So what does that mean? Well, like I talked about in the previous example, to find the perimeter, all you really need to do is multiply by the one side by the number of sides only when all of the sides are congruent, which is this case because we are dealing with squares. That will not work with a rectangle or any other type of triangle or quadrilateral where the sides are not the same. Okay, so I could just take 64 and divide that by 4, which will give me 16. That means each of these sides is 16. These congruency marks here are making clear that I have 8 and 8. I now have a choice. I could use Pythagorean Theorem, just like I did the first time, or I can use trig. The only reason why I'm going to use trigonometry in this problem is just because that was the purpose of the video. But if you want to use Pythagorean Theorem, like I did in the square example, you absolutely can. So I am going to get rid of this side and call this 45. And now I'm going to go through the process of performing trig. Okay, so this time I kept the 8 over there, and when I cross multiply, or when I label my triangle, I'm going to end up using sine this time. In the first example with the square, I made clear you could use either cosine or sine, depending on which side you decide to use. Okay, so here's the contrast. So now, I'm using sine again. So sin 45 equals 8 over x. I am going to turn this into a proportion by placing the 1 underneath here and cross multiply. So that's 8 times 8 equals sine 45 times x. Then I'm going to divide the sine 45 to both sides. If you're starting to see a pattern in these triangles, you don't even need to use trigonometry anymore. I kind of recognize it, but I don't use it that often, so I forget, and I always just punch in the calculator just double check. So I got 8 square root 2 here. So that means the lengths of these sides is 8 square root 2. Okay, so all I have to do is square that. Once again, the area of a square is side squared, so I'm going to plug that in. 8 square root 2 squared, 8 squared, square root 2 squared. You could skip most of these steps if you're getting more fluid with this stuff. So 8 squared is 64 times 2, which is 128. So that means the area of this square, the area is 128. Alright guys, I hope you have found this video helpful.